Even those fancy things like data science, big data, cannot work properly if we don't have high-quality data in place. The second step is processing. So here the data is divided into 3 layers: bronze, silver, and gold. And this division in 3 layers, in bronze, silver, and gold, is a well-established concept in data warehousing. So bronze data, bronze layer is like a raw ingestion layer. Silver data is already cleaned, so it's transformed data. It can be also like filtered, normalized, enriched with necessary columns. And the final layer is gold. So this is the most valuable data for data analytics. It may have already business-level aggregates, estimates, predictions generated by machine learning and AI models. The goal for DQ framework is to build and configure such a system that will allow us to catch the problems before they are spotted by the data users. The division of the data, the split of the data itself in bronze, silver, and gold, allow us to make our platform observable. With these loosely coupled components, this architecture allows to develop, deploy, modify, scale these separate modules without affecting the whole application. So it has some agility benefits. And now let's quickly go through all that connection between the microservices is ensured by DocumentDB integration bus. So, and if, for example, one microservice fails, the next step is impossible, so the whole process stops. We really need to know the data we are working with. So knowing your data should be part of your strategy. So nowadays, fintech companies get their data from multiple data vendors. And this data can be on different financial products like options, crypto, bonds, funds. So this is just examples. It's not a full comprehensive list. And generally, financial data can be categorized as master, reference, transactional, and history. For example, the first priority is timeliness. We want to get our data in time. And if we have cases when vendors do not deliver the data on time, we need to apply a SLA check. So to check whether we get the data in expected time period. And now, when we are aware about our problems that we have with our data, we may think about those checks we need to apply at each step of data processing. Now, I think it's high time to present you how we actually integrate our data quality framework with the cloud, with our data platform. Let's say daily file appears on data vendor source. Then we have our first microservice acquisition started. So this acquisition microservice starts the process of onboarding of that file to our data platform. After it finishes, the first DQ microservice kicks off. Completion of this DQ microservice, next microservice starts its work, like standardization. Then it's followed by next DQ microservice. So as you see, those microservices are alternating each other. And then all the results are written to Databricks tables. So this is the logic how it works. We also calculate some statistics, like how many rows we process every day, how many rows actually have issues. Also, we set up alerts and notifications, like, for example, SLA check, when we, for example, do not get the data when expected, we get the notification on our mailbox. We have notifications from Datadog and CloudWatch service from Amazon. So this is the example how we break down our data quality issues. We can see the information, how many vendors are affected, how many data sets. So the breakdown of data quality issues per check type. We see also how many of issues are open, are in resolved status, closed status, and at the bottom, the total number of issues.